All right, so let's look at the concept of concentration, and specifically when I say concentration, the concept of molarity, or mole per liter, as you might know more colloquially. So this is once you dissolve a compound, you need to know what the concentration is of that compound in solution. And specifically, what is important here is, or for now, is what we define as molarity. So it's a concentration unit. So molarity, C, or you'll see some bracket notation just now, is defined as the amount of solute, so meaning the thing that you are dissolving in mole, divided by the volume of the solution that you have. So let's look at that maybe a bit pictorially. So let's say, for example, you have a volumetric flask here, and you have some sodium chloride. So that's a physical thing here, right? So sodium chloride is like a little heap of stuff that you are going to add into this beaker here, or beaker, volumetric flask, and you have some water that you also want to add. So you have an empty flask, water, and sodium chloride. So you have enough water, and this is a 1 liter. Let me not draw it like that. This is a 1 liter volumetric flask. Okay, so it's 1 liter. And you place your sodium chloride in the flask. Okay. And then you start filling in water. You dissolve the sodium chloride, you shake it a bit, and then you start adding water all the way to the mark there. The question is, how much water would you have added to get to that 1 liter mark? Would you have added exactly 1 liter of water to dissolve the sodium chloride? Or might you have added just a little bit less than 1 liter? Because, thinking of it, if you're going to dissolve something and you start adding water then, and you fill up something now that tells you when you just reach a point, so meaning a measurement point here that tells you that's a 1 liter mark. Doesn't the sodium chloride also take up, if you want to call it, space in this volumetric flask? So meaning not all of the space occupied in that 1 liter is water, right? It is 1 liter of solution. So it's 1 liter of solution that we have made up. Yes, that is correct. But is it 1 liter of water that you used to make that solution? No, right? Because there's some sodium chloride as well. So the sodium chloride plus the water is 1 liter, but there's a little bit less. So it's like a little bit less than 1 liter water and some sodium chloride that together makes up 1 liter of solution. And that's the concept of what a concentration is. So you can say less than 1 liter of water is used. And this is why it's a very subtle definition of what concentration is, molarity C. It says it's the amount of solute, so that's your number of mole of your sodium chloride, so your powder, divided by the volume of solution. So in other words, yes, you're going to use this value. You're going to say 1 liter, so you're not really cared about how much water you added. You could have added 0.999 liter of water, but you care eventually about to what point that you add that volume. So it's the volume of your solution, not volume water added. Okay, and you'll see how we normally state this. We say something like enough water is added to give a solution volume of 1 liter. Okay, so like this sentence here says, for example, if we take so much mass, so 1 mole of sodium chloride is dissolved in enough water to give a total solution volume of 1 liter. Okay, so that's typically how we make up solutions. We say there is enough of the solvent is used. Then we define this molarity concept. All right, so that's my little introduction to it. So let's finally now look at what is molarity. So like I've now said a couple of times, molarity, C, is equal to this NaCl divided by V solution. All right, and you might sometimes see people write bracket notation. So you might have seen this before, right? You say the brackets, that's the concentration of something, bracket NaCl. And this is typically written as, well, 0.1 molar, right? And molar is written as, that means 0.1 mole per liter. That is what molar stands for. Stands for moles per liter. All right, I'd say it here somewhere. All right, so this mole per liter, this capital M means mole per liter. All right, so that means you dissolved 1 mole, or how many ever moles, or whatever that number is, gives you the amount of mole of this solute, the thing that you have dissolved, in 1 liter of solution. Okay. All right, so that should give you a nice idea and how to work with it. So let's try and get our hands a bit dirty with the concept with a nice basic example. And this one, it says if we take 25.3 gram of sodium carbonate is dissolved in enough water, right? Enough water to make 250 milliliter of solution. All right. What is the concentration of sodium carbonate? What are the concentration of the ions? So that's an important point. So we'll talk now about what that second part means. But let's just get the basic part. So the question is, right, what do we know, right? We know the mass of the solute. So if we want to get the concentrations, so meaning the molarity, we need the amount of the solute and we need the volume of the solution. We're told the volume of the solution. We're told enough water to make a 250 milliliter solution. So that means we need the number of moles of the solute. Sodium carbonate is the solute. We're given the mass. So we basically just need the number of moles of the solute, and we can use the molar mass to find that. So our first step is to determine number of moles of sodium carbonate. Sorry, I just want to get a bit of a less thick writing utensil here. CO3, 25.3 gram sodium carbonate. All right, so typically you can divide by the molar mass, but that is the same as saying 1 mole of sodium carbonate weighs whatever the molar mass is, 106.0 gram Na2CO3. All right, giving us 0.238 and some numbers mole sodium carbonate. Okay. And then to get the concentration, so whatever you want to call it, you can call it bracket Na2CO3, you can call it C, and then subscript Na2CO3, All right. So the concentration, or you can write out concentration of sodium carbonate is then just this number of moles in a 2CO3 divided by the volume of the solution. So meaning it's the 0.238 mole divided by 250 milliliter, but we need a volume of solution in liter. So we just need to remind ourselves that 250 milliliter, 250 milliliter. So we want to get rid of milliliter, we want liter, so 1 liter. There is 1000 milliliter in 1 liter. In other words, that gives us 0.250 liter. So 0.250 liter. And you can round this because that's the first part of the question. So that gives us 0.955 mole per liter, or molar. All right. Cool. So that's the first part of the question. Now the question is, what are the concentrations of the sodium plus and the carbonate ions? So are they the same as the sodium carbonate? What happens to sodium carbonate if you put it in water? If you take this solid and you solivate it, what does it split up into? It splits up into sodium and carbonate anions. But notice here that there are twice as many sodium and cations as there are carbonate anions. So wouldn't that have an effect on the concentration? Ask yourself that. If this is 1 to 1, and this is, and the other one is 1 to 2, does that have an effect? Meaning you have twice as many sodium ions as there are carbonate anions. And the answer is yes, right? So concentration CO3 2 minus is equal to the concentration of the overall thing, 0.955 molar. But the concentration of the sodium will be twice that. And why? Because for every 1 mole of sodium carbonate, there are 2 sodium atoms or sodium ions that come from it. So in other words, this must be 1.91 molar. Okay. So meaning physically, if you break up sodium carbonate, there will be twice as many sodium ions that come out or propagate into the solution as there will be the carbonates. So just looking at this purely here, right? So meaning 1 to 2, meaning that these numbers here can't physically be equal, right? This meaning this has to be 1 to 2. Okay, maybe that helps you understand it a bit better. Okay. Also, while we on the topic, even though you sometimes write salts as having a concentration, that's not really a physical interpretation of it. Salts don't exist in solution, right? So it's always the ions that are in solution. So just be aware of that. Cool. So have a thought about this point, because it's a good point, or it's a very subtle argument to have, but it's So look at some salts and think about how do different how do different ones act, um, and how you can envision it for yourself. Cool. I'll see you in the next video.